This video is going to cover Unit 27, Section 5, Areas of an Ellipse. So let's talk about an ellipse. So we've got an ellipse right here. With an ellipse, you have two axes, okay? One of them is the major axis, so that's the long one. And the other one is the minor axis, which is the short one. Major axis goes from this point to this point. The minor axis goes from this point to this point. Okay? Now within the ellipse itself, we have links A and link B. A is equal to 1/2 the major axis. B is equal to 1/2 the minor axis. Okay? Now I want to compare an ellipse to a circle. With a circle, you can think of it just for a moment. Let's just think of this. Let's think of this as the major axis. And let's think of this as a minor axis. Okay? And then let's think of this as A and this as B. Now, a circle is similar to an ellipse in that it does have two axes, and it's got a distance from here to here and a distance from here to here. Now the difference between a circle and an ellipse is that the major and the minor axis are the same. So A and B are the same. So the area of a circle is equal to A times B times pi. Well, we know that A and B are the same. We also call them the radius, so it's the same as the radius times pi, but we generally just write it as radius squared pi, or pi r squared. It doesn't matter the order. So for an ellipse, the area of an ellipse is equal to A times B times pi. The difference here is that A and B are not the same numbers like they are with a circle. So we find the area of an ellipse almost the same as we find the area of a circle. The similarities are there. Now, I want to be very clear. This is one of those things where every term, more than half, 60 to 70% or even more, people still make the mistake. When we find A and B, we need to remember that they are half of the major and minor axes. They are not the major and minor axes. So when you're given an ellipse and you're told that the major axis is 12 and the minor axis is 8, and then find the area. Well, a lot of people, it just happens, 12 times 8, that's how they go for it. What they do it. But A is equal to 6 and B is going to be equal to 4. So the area of an ellipse with a major axis of 12 and a minor axis of 8 is going to be 6 times 4, which is going to be 24. You need to cut the axes in half. Or if you're given A or B and you're asked to find the major or minor axis, you double them. All right? So let's take a look at page, areas of the ellipse. Okay, 695, a little bit below halfway, figure 27-41. And what we're given here are the major axis, the minor axis, and the area. So we're going to be given 2 and asked to find the third. So let's take a look at number, let's look at number 12. So we have the major axis is 80, my gosh, I can't read that, 86 millimeters, okay? And then the area is 4,730. They need to print that a little darker. Okay, so let's take a look at how we would find this. So let me just write the equation. Well, I've got the equation right here. So I will say 4,730 is equal to, what do we have, the major axis? So we're looking for the minor axis that's associated with B. So I'll write the B first, and then I'm going to write the A. But what is the A? It's half of 86, which is 43, and then pi. Oops, 3.14. Okay, so I'm just going to multiply these two numbers together here. So 43 times 3.14 is 4,730 is equal to B times 135.02. I could probably just drop that. It's already been rounded with the 3.14, but I'm not going to. So to find B, I need to divide by 135.02, divide by 135.02, so let's do that. 4730 divided by 135.02 gives me B, and B is 35. Close enough. I can round one more time. So that is B. Okay, so that's what I would put. Okay, the battery in my camera died, so we're going to finish this up now. Where we left off, which was for you maybe a half a second ago, for me, could have been a couple of days, we found B for number, what number was that? I gotta think it was, it has been a while for me. For number 12. Okay, so what I was about to say was, now we've got B, so we put that in for the minor axis, right? No, we've got to double that. Remember, B is half of the minor axis. So the minor axis, what we would actually put in for the answer for that problem right there is 70. Okay, double B. So don't forget that. That is something that people miss all the time on these types of problems. The minor axis is not what you use in the equation. You use half of the minor axis, which is known as B. You use half of the major axis, which is known as A. All right, so let's do one more of those. Let's do number 10. And I have the area is, let's see, square feet, everything is in feet. 1215, that's my area, and that is equal to the minor axis, once again, we're looking for B again, times the major axis is 43, so half of that is 21.5. And then multiply that by pi, which is 3.14. And let me multiply these two together first. So 21.5 times 3.14 is 67. So I've got 1215 is equal to 67. What is that? Oh, I was going to put 51 B. So divide both sides by 67.51. So 1215 divided by 67.51 is equal to B, which I'm going to round to 18. So B is equal to 18. So therefore the minor axis is going to be 36. All right. So I can't stress it enough. It sounds like I'm beating a dead horse, which isn't really good to do because it just kicks up the flies. But I know I'm repeating it a lot, but that's because the mistake is made all the time. So be aware that A and B are only half of the major and the minor axis.